this video, I'm going to talk you through the initial steps of the data processing for labP. I'm going to show you how to find the equivalence point. So that'll mean the pH at the equivalence point as well as the volume at the equivalence point. And I'll also talk about finding the half equivalence point. So therefore, I'll be looking at a titration graph of pH versus volume of titrant for a weak acid with strong base. In front of us, we have an Excel spreadsheet, and the data from the titrations have been imported. Initially, your data will be in columns A and B, both for the strong acid with the strong base as well as the weak acid with strong base. I've moved the data for the weak acid with strong base into columns D and E so that it's a little easier to work with. I'm going to select the data, as we always do in preparing a graph. The volume is on the left hand side, the pH is on the right hand side, and therefore the plot will be made appropriately. Like before, we're going to select insert and then over here the scatter plot, but I don't want just a simple scatter plot because I do actually in this case want the lines attached. So I'm going to select in a sense a drop down menu and bring my mouse on top over here. This is scatter with smooth lines. Okay, so I'm going to select this, and at this stage I want to make very clear that the sort of data processing that you need to do here in terms of producing the graph that you will cut and paste into Word is the same sort of data processing that you've done before. So for instance, you're going to need to remove the chart title. You'll need to label the y-axis, label the x-axis, include the units, remove the grid lines, remove any kinds of borders, put in tick marks. So all that sort of data processing still applies. What I'm showing you here is what you may want to be doing before you do that more fancy kind of data processing when you still have the grid lines, because the grid lines will be useful to us. So you can see I've enlarged my graph. This is going to make it a little easier to work with. And I'd like to get the equivalence point based on analyzing this graph. Now at first you may find that what I'm doing here looks rather crude, but I think you'll see with some persuasion that actually we can come up with the volume at the equivalence point with a fair high degree of precision to at least 2 digits past the decimal place, and that's definitely as good or if not better than using any kind of indicator. So the first thing that you're going to want to do is to draw lines that run parallel to the slope of the pH versus volume before the titration graph has the drastic change in pH and after the titration graph has the drastic change in pH. So to do this, I'm going to come here to insert and then over here a small icon that shows shapes. I'm going to select the line shape. So at first here I'm going to draw the very best line that's going to match the slope of my graph after the drastic change in pH. Let's see if this works. Yeah, it looks pretty good. Okay, and I want to run it a little bit over this way. Okay, so I'm trying to line up my lines in a sense, essentially as the graph is flattened out. And then I'm going to pick, once again, insert and select a line and draw the best slope I can based on the shape of the graph before the drastic change in pH. So there is a little bit of estimation going on here, but missing it by a little bit won't make that much difference. So now I've got 2 lines. They're roughly parallel to one another. I'm going to draw a third line, and this third line should intersect each of these original lines, but also intersect with the drastic change in pH. So I'm coming down here. I may have to adjust the line a little bit, and I'm actually going to bring the line all the way down so that it intersects with the x-axis. Okay, and now I need to move this line a little bit so that it definitely runs through the drastic change in pH. And the idea here is we want to find halfway through this drastic change in pH and between the 2 slope lines, because halfway through will represent the most drastic slope, and the most drastic slope will correspond to the pH at the equivalence point. Now I'm using the grid lines to guide me a little bit here, and I can see that roughly speaking the line at the bottom here is starting close to the 6, and roughly speaking the line goes to about 11.5, and so we're looking at around 2.75 units, pH units, to get halfway up to this drastic change in pH. So you can see there is a bit of an estimation going on. The fact that it's not going to be a perfect estimation is not actually a problem, as you shall see. So I'm looking to go about halfway up here at around 2.75 units. So going from 6 to about 8, that's 2 units, and then I'm going to estimate going up not all the way to 9 to about 8.75. And just so you can see where I'm aiming, I'm going to draw another line here, and I'm aiming for about 8.75. And you'll see there's no exact data point to match that, but we'll find the best data point that we can in terms of the various data that we collected. So the pH at the equivalence point is about more or less where I've indicated this intersection. This is why it's now important to go to the actual numerical data, and why we do this analysis while we're still in Excel. And I'm looking for a data point near 8.75. So looking at the numerical data in columns D and E, in column D we have the volume data, and in column E we have the pH data. And so here I've got 8.55 pH units, 9 pH units. So we're looking for a volume of titrant that's going to match our pH value of 8.75. Now we don't have that exact pH. We can see that the 8.75 is a little bit closer to 8.55. It's only off by 0.2 pH units, and it's off of 9 by 0.25 units. So somewhere in between the 8.55 and the 9, a little bit closer to the 8.55. So when I look at the corresponding volumes, I have 17.11 and 17.18. So not exactly in the middle, but a little bit closer to the 17.11. And so that might be around 17.14. Now this may seem a little crude to you, but realize that what's different between these different points is one drop of titrant. Now if you can stop a titration using a color indicator within one drop, you are doing a very good job. And in a sense we're actually stopping it using a half a drop. So I'm going to choose 17.14 as the volume at the equivalence point. Okay, so down here this would be roughly 17.14 mils. Now we are also interested in the volume halfway through this titration, because as we know the pH equals the pKa at that point. So taking half of 17.14 is 8.57. So just to show you that point on this graph, I'm going to draw another line, and again this is going to be a crude estimation on the graph, but around 8.57, it might be somewhere around there. Whatever the pH is at that point is equal to the pKa. And so once again I'm just going to show you what we're aiming for. We're not going to be able to read the point off directly from the graph because the graph doesn't have enough level of precision. So I'm trying to draw the best straight line I can. There we go. Okay, so roughly speaking, the volume halfway through the titration is at about 8.57 mils. I'm interested to know, well, what is the pH that corresponds to this 8.57 mils? So what I'm going to do is go back to my numerical data, and remember the volumes are in column D. So I'm scanning back and I'm looking here, and I'm looking for around 8.57. Well, once again, I don't have an exact point at 8.57. I've got volumes at around 8.68 and 7.19. So it's actually just slightly below 8.68. So once again, I'm looking for a volume of 8.57. So therefore the pH that I'm interested in is just slightly below 4.9. Now it's not going to be a pH of 4.8, because 4.8 would actually be a volume considerably lower than 8.68. So we're looking at more like something like 4.89. So just a slight decrease in pH. So I would estimate that the pH halfway through this titration is going to be occurring somewhere around 4.89. That would be my estimation of the pKa for my weak acid. Now, interestingly, the pKa for acetic acid is around 4.75 to 4.8. So my estimation around 4.89 is not bad. So these are the values that you would be recording in your report sheet, and you'll see that there are spots specifically to record those. It comes from doing this sort of analysis before you do your further data processing to make your graph look presentable. Now, I actually don't need to see these lines. I need to see the results of you doing this analysis, and I'll be able to look at your data and to see if it's reasonable in terms of what you've come up. If you want to include these lines in your final graph, that's okay. But I definitely don't want to see the grid lines. I want to see proper labeling of the pH, the volume of titrant, all the things that we've had before. So I'm hoping that this little presentation has been helpful in helping you determine the equivalence point, and that includes both the pH and the volume, and halfway through the titration. What you see here will also apply for the strong acid, strong base titration, except you won't have to worry about the halfway volume.